Baby Shawties, how we doing? Welcome to Chapter 7. So, as we go through this little hiatus from school, know that for every section we go through in this chapter will be a video lesson that we're going to go through today. So, on Google Classroom, you should see the notes for this posted. If you have the opportunity to print those notes off, that'd be great to follow along. Otherwise, you can follow along on a separate sheet of paper. Key thing is that if you have any questions on any of the stuff that's covered in here, make sure you jot those questions down, post them on Google Classroom, send me an email, whatever it is, to make sure you get that stuff clarified. Remember, as you go through this, you're able to pause the video, you can rewind and go through anything that maybe confuses you. All right, so what we're going to talk about in this chapter is we're going to look at quadrilaterals. So last chapter we focused primarily on triangles and different segments within triangles. So in this chapter we're going to look at a quadrilateral. So in general, now we're going to start getting into after we deal with triangles, which is our simplest of all shapes, we start to get into when we add different number of sides or add different number of angles, that we get in different shapes. So understand that we're looking at what it's called a polygon. And a polygon is any sort of shape with a set number of sides and an equal number of angles. So, we dealt with, for example, last chapter, triangles, which have 3 sides and 3 angles. This chapter, we're going to focus on what are called quadrilaterals, which have 4 sides and 4 angles. You can go up to pentagons all the way up to 10 sides, 10 angles would be a decagon, and you might see some of these other terms used. So this section we're going to focus primarily on polygons, but what we're going to look at, it's going to relate to something you guys learned about in one of the early chapters, but we're going to look at some of the relationships here within a certain number of polygons. Specifically in this chapter, or this section, we're going to look at the angle sum within a polygon. All right, so there's different types of polygons we can see. So these are kind of the breakdown of how we can classify a polygon. So you might see polygons that have a certain number of sides, but those sides can be congruent, meaning equal. So if we see a polygon that has all the sides equal in length, that's called an equilateral polygon. Lateral is just our fancy way of saying sides. You can see polygons where all the angles are congruent. That's called an equal angular polygon. And then the real nice polygons, which we see a lot in everyday life, are what are called regular polygons. Regular polygons where all the sides and all the angles are congruent. So these are some possibilities with different types of polygons we can have. All right, so what our goal is for today is to focus on whether we have a 3-sided shape, a triangle, or all the way up to 10-sided shapes, a decagon, whether they're regular or not, or equilateral. What we're going to look at today is focus on the internal angle theorem. So you guys should have done a little exploration activity on this idea already. So hopefully this is kind of just summarizing things. But the internal angle theorem focuses on the sum of all the angles inside of any sort of polygon. Okay, so whether it's a triangle, which has 3 sides and 3 angles, what this is going to look at is what is the relationship between those 3 angles. Now, what you guys should know already from previous chapters is that if we have, for example, a triangle that has 3 angles, we should know that the 3 angles, call them A, B, and C, that if I were to add up all those angles together, that all 3 of those angles should add up to a total of 180 degrees. So this can be true then if I were to then say add in a 4th side and make it into a 4th angle. Your goal was to understand or look at the relationship of what happens. So all starts off at 180 degrees, but if I were to add a 4th side, you should have recognized it got all the way up to 360 degrees, and it kept essentially adding 180 degrees every single time. So we can summarize this into a formula. This is called the internal angle theorem, that the sum of all the angles inside of a polygon is going to be related to the number of sides within that polygon. So for example, if I have 3 sides, that it should add up to 180 degrees. Excuse me. If I have 4 sides, it should add up to 360 degrees, and so on. So here's the relationship. So you have n minus 2 times 180. Now n is going to represent the number of sides. Where this part of this comes from is when we have, for example, a triangle. So the triangle is the first type of polygon we can have because I cannot make a shape with 2 sides. I can only make an angle. So the minimum number of sides we need in order to make a polygon is at least 3 sides. So that is why you're going to see the n minus 2, because if I plug in a triangle which has 3 sides, 3 minus 2 would give me 1. So it's going to take the number of sides minus 2, which in this case would give me 1, and then it's going to multiply it by 180, and that would tell me the number of sides within that shape. So if, let's say, for example, I want to know how many, or what would be the angle measure of something that has, let's say, 10 sides, I would plug in 10 for n, and this formula will allow me to solve for the number of sides. So we're going to use this to figure out what would be the sum of all the angles inside of a polygon. We're also going to use this in reverse to see if we can figure out the number of sides a polygon. Okay, in this first example, we're going to look at classifying the polygon, and then we're going to find the sum of all the measures of the interior angles. So to classify, simply what we can do is count the number of sides. So in this first diagram, I would have, counting up the sides, I would have 8 sides. So I know that this is UFC going to be an octagon. Tough. If I were to classify this even further, I know that the sides are not the same length. The angles kind of appear to be all the same, so this might be an equal angular octagon. But nevertheless, it's an octagon because it has 8 sides. So if I want to find the sum of all the interior angles, okay, knowing that if it has 8 sides, it's going to have 8 angles, and I could label those 1, 2, 3, 4, 5, 6, 7, and 8. So it's got 8 total angles. So if I want to know what do all those 8 angles add up to, I can use the formula n minus 2 times 180. So again, n minus 2 is representing the number of sides. So I'm going to take 8 minus 2, and whatever I get there, I would multiply by 180. So knowing that 8 minus 2 is 6, I'm going to take 6 times 180, and that's going to tell me the sum of all the angles, which in this case would give me 1,080 degrees if I were to add up all the angles together. All right, next one we have a 4-sided shape. So 4-sided shape, okay, this one appears to be, as we know, probably a rectangle. This one would not be equilateral again, but it would be equal angular because all the angles are the same. But we have 4 sides, so if I want to know the sum of all the angles, I would take 4 minus 2. 4 is the number of sides, and multiply that by 180. 4 minus 2 would give me 2. Multiply that by 180, I'm going to get 360 degrees. And again, the reason why there's that minus 2 there in both of these formulas is because the minimum number of sides that I need is 3. So we're kind of taking away minus 2. Think of a triangle. 3 minus 2 would give me 1, and we know that a triangle has to add up to 180. So again, the n minus 2 is there because we need at least 3 sides to make a polygon. All right, why don't you try this last example, number C, on your own. We have the Canadian dollar there, so figure out how many sides that coin has, and then see if you can figure out the sum of those angles. All right, it should be 11-sided shape, so an 11gon is what we would call it, and all the angles would add up in this case to 1,620 degrees. Again, 11 minus 2, 11 is the number of sides, times 180 would give you that. All right, next one, we're going to kind of do this in reverse. Now I'm going to give you the angle sum, and let's see if we can actually figure out the number of sides. So we are going to use that same relationship where the number of sides minus 2 times 180 is going to give me the sum of all the angles. Okay, so here you are told that the sum of all the angles of this polygon adds up to 900 degrees. Okay, so what we're going to do is we're going to classify this polygon. So I know that all the angles are going to add up to 900 degrees. So that n minus 2 times 180, I know should equal 900 degrees. So what I kind of did right there is set myself up a little mathematical equation. And what we're going to do is we're actually going to do this in reverse. So think of the formula, I would do n minus 2 times 180. So I'm going to do the inverse. So first I'm going to divide both sides by 180. By doing that, I'm going to get 5. Okay, so that means that n minus 2, the number of sides minus 2 is going to equal 5. Now to be careful here again, because of that minus 2, know that we don't have a 5-sided object, but we now have to undo that minus 2. In this case, we'll add 2. So that means the number of sides of this object would be 7. So this would be a 7-sided polygon. Fancy name called a heptagon. Heptagon. Hepta means 7. All right, so we're going to do the same thing. Now we have 1,800 degrees. So our goal is to figure out the number of sides. So we're going to set this up the same way. I know that n minus 2 times 180 will give me the sum, and I know that the sum here is 1800, so we're going to do this in reverse. So I'm going to divide both sides by 180. That would give me then n minus 2 would equal, in this case, 10. So then if I add 2 to both sides, I would get a 12-sided object. Boom, done. Okay, so again, using that formula in reverse should tell me the number of sides of that polygon. All right, last example here. Now we're going to use the interior angle sum to try and solve for unknowns. So as we go through this example, we're going to need to know, like we did in the last one, what would all the angles add up to, and then we're going to try and find that missing angle. So in our first one here, we have a 1, 2, 3, 4-sided object. So what I'm going to use is my interior angle sum theorem, and know that 4 minus 2, 4 being the number of sides, times 180 is going to tell me what all the angles should add up to. And again, we did this one, a 4-sided object should add up to 360 degrees. So I know all of these angles inside here have to add up to 360, and notice I give you 3 of the 4. So that means we're going to take the 3 angles I'm given, 108, 121, and 59. I'm going to add those 3 angles together, which would give me 288 degrees. And again, I wanted to get all the way up to 360, so I'd have to subtract that remaining amount, which in this case should give me 72 degrees. So I know that that missing angle would be 72 degrees. All right, so I want you guys to try example B on your own now. So think about the number of sides that it has. Use the interior angle sum theorem to figure out what all the angles should add up to, and then use that to find that missing angle. So go ahead, pause the video, try this one on your own. Okay, so I got 720 degrees for all the angles. We got 6 sides there, so that means it's going to add up to 720. I added up all the angles you're given to 613 degrees. Took that away from 720, which again is the total. Got 107 degrees, I'm sorry. All right, so this again is looking at just some angles within a polygon using the relationship between the sides and the angles. Again, something that we knew already for triangles, but now applying it to different sorts of polygons. So again, if you have any questions, jot those things down. If you need to go back and rewatch something, do that. Otherwise, check Google Classroom for the assignment. Good luck, guys. We'll see you next section.